My talk is called The Mad Science of Node. I enjoy doing weird things with Node and Node Core. A lot of it doesn't work out really. I have spent many hours working on patches and improvements and fixes that just totally crash and burn. But I don't care. But you guys might be asking yourselves, well, why bother working on this stuff? Why take time coding this and working so hard to figure it out just to have it fail on you? Because you're working on something that nobody even agrees with. Partially, I do it because I get bored. Looking at all the same types of patches, like, oh, you have a security flaw that lets somebody hack you. It's like, yeah, whatever. I really, rather work on, the types of things that make your brain twist. Also, it allows you to view problems from a different perspective and be reminded, like, this is code, right? We control it. It doesn't control us, and we can put ourselves into it and tweak it however we want. We just need to figure out how to do that properly. And some of it might actually become useful. I have one example. I had one proposal to Isaac. This was way back when I first started in Core. I had one proposal to Isaac, and I presented to him on the mailing list, and he responded back basically like, yeah, right. Okay, if you can prove that out, go right ahead. But he was completely doubtful, and was for about a month. It took me that long to refine this, what is now kind of a basic thing. Let me show you the code really quick. So, right, this is part of Core in the source Node.js file. This is what you get on boot. Now, down here, so when you run process.nexttick, it loads all the callbacks into an array. And so you see here, it's pushing it into an array, right? You're like, okay, great, well, you have the array length. That's fine. But then you see directly underneath, we have this tick info k length that we're manually keeping track of. And you're like, why? Why would you do that to yourself? And then if we go above, you can see that we're actually iterating on that length over the entirety of the array. We're actually not, we don't even care about the actual array length, we care about this length here. And then if we switch over to the C++ side, you can see right here, this info length, right? That length in C++ is actually the exact same data that's being transferred to us in JavaScript. And so we're reading that from a native struct and checking to see if the array, or if the callback array is empty, and if it is, we're returning early, one step below. And the way we do that is using an array buffer. And so what we do is we allocate memory, right? And we pass it to an array buffer, which gets thrown up in JavaScript. But then we also keep an internal reference to it. And so both JavaScript and our native API have the same pointer that they can read to and write from. And what this does is bypass all the cost of passing variables back and forth across the layers, because both of them write directly to external memory outside of the heap. And we found this to be, well, very, very performant. It's basically a no-op, and it's saving us a lot of unnecessary calls back into JavaScript after, for modules like crypto. If you're doing a heavy load, it can save you 30,000 calls per second up into JavaScript that you didn't need. So this is one example of one of the mad science things that I did that took a month or two to work out, but it finally made it, and now it's in Core. Now all the new developers come in and say, what is this? Like, why is this here? So I get to re-explain it. And then afterwards, you're like, what? Why? But so if you're exploring node source Core and you can't figure out what's going on, I'm probably the reason. So if you have any questions of why, just hit me up on IRC and I'll be more than happy to explain it. So, first quick hack. Now, I owe this one to Bradley Meck. He introduced me to it. Now, strict mode technically does not allow you to define variables on global, right? Yeah. No, not really. It does. Like, just doing a little, new function evaluation hack, and you can throw it up on global. So then going from there, Continuing on with that, strict mode definitely does not allow you to grab the this, like if you call this within an anonymous context, it returns undefined, right? Well, not so much, because remember, the context of a function is that which it's attached to, right? So since we can pollute the global namespace, we can then pollute it with a function that returns this, and then we can grab global despite being in strict mode. So not that this will ever be useful to you, but just in case, just in case your environment wants to protect you, you can say, no, I know better than you, and get access to global and do whatever you want. So, also, this is just a quick note. I thought of it a little while ago, and it's one of those, oh yeah, it does, after you realize it, but you just probably didn't think about it. But native modules don't need a native module to run. If you have access to buffers and file system write, you can run a native module. Because what you can do on your system is compile it, and then read it in, and buffer.toJSON on that data into a file. And that's valid JavaScript. And then when you start up your application, you pass that data object through a buffer and write it directly to disk through write file. And then all you have to do is require it, and you've executed native code through JavaScript. So, and what's great is because of like os.platform and all that stuff, you could even compile it for several different variants, keep them all in a JavaScript file, and load them all in depending on the system stats that you get on startup. So, well, yep, there you go. Yeah, I'm still working on how to get it to execute directly from memory so you can bypass the file system. If FFI makes it, you can, but right now it's not in. Well, I think, still working on it. So function generation. This is like, not so mad, but maybe useful. So in the beginning, there were strings and search replace. Like if you ever needed to generate a new function on the fly, right? You keep a function instead of a string, and then you replace the parts of it with like basically search and replace. And then there were template strings, like, oh, this is so much easier. We can just do evaluations within code. But you know what? Either of those still really suck, especially if you're using an editor that has like context highlighting or like any kind of autocorrection. It's like you're in a string. I don't know what you're doing, right? Well, why not just keep it in a function? So here on the top, I have a function. Now, it is using 2 undefined variables, right? But it's just a normal function. So I can write this out, and it can do syntax correction and all that normal stuff. And below it, I pass in the function, and then I pass in an object with the names and the replacements, right? And then here I'm doing the toString on the result. And see down there below, you can see that it replaces with 42, and then it replaces the brackets, actually. It will detect if it's a string and replace it with the dot syntax. This is actually a module that I created a little while back, so it works. It also works with generators. I don't have it working yet with arrow functions because those just barely became available. But yeah, this actually does work. So, dynamic modular reloading. Say you're running your application and you decided, man, you know what? This is up and running. I would really like to just be able to require it again and not have to restart it. Like, how many of us have ever thought that? Oh, really? There are. Okay. All right. So it does require a specific pattern right now, but it is actually possible. So here, I'm loading this module, and I'm creating a new instance from the module. This gen data just generates a set of random data. And then, oh, hey, look, arrow functions. Right here, I have an interval. Every 3 seconds, it's just going to print out the sum of the random data, right? So if I run it, it's just going to print out the same value every 3 seconds. Now here's the code, right? Now it's just taking it, processing it, and returning it. I'm like, oh crap. Well, all I want it to do is return 42. Whoops. Yeah, is that 42? Well, all right, I'll make the change. I guess I'll save it. And, oh, hey, there we go. You just changed it. All right, great. So I just reloaded my module live. So, I mean, like, I can really do, I can do whatever I want at this point. Oh, yeah, doubled it. There we go. So, this way of programming is actually kind of a pain because you need to, basically, you need everything to live in an outer scope of your module because when it gets replaced, it needs to replace everything. Now, it'd be easier with a simplified case, but since I was solving for the general case, where, like right here, I have a, I'm creating a new instance, right? A full new instance, and then I'm working with that. So then, here I'm returning a new object. Now, why can't you use a constructor? Anybody have an idea? Why can't you use a constructor? Because the .constructor property will be the old function that you've reloaded on top of. So you can't use new function name, right? You have to just return a good old, man, I'm still putting out numbers. You just have to use good old objects, or else old code will still be available, and it'll also just eat up garbage because it can't be cleaned up because of your old instances. Now, as you can see, I have this weird little, like you have to do all this weird indirection, where here my gen data and my sum data are returning this .me gen data and sum data stuff, like the GUID, right? All these are defined at the top here. I just made up that random key. I'm making sure that this live modules object on process is live, and then I'm adding it if it doesn't exist. And then I'm setting a reference to it afterwards. But then below that, see, you can see on the global, I'm actually setting all the functions. And so all the functions internally that are exposed to the user, whether it's an instance function or exported directly on modules, it has to have an indirection call back up to this global that you can then wipe and replace on the fly when you reload your module. And so it's actually, it's ugly. It's not that difficult to get, but it is ugly. And then further up, this reload, this is a total hack, but I'm deleting the npm, I'm deleting the module cache for the module that I've loaded, so that it thinks that it no longer exists, so it force reloads it. And then I'm just re-requiring it. But the advantage of this step is this is actually running within the synchronous context of re-reloading. So for a brief period of time, you are within, you are in an old function loading a new function, right? Loading a new module. And the reason you would do this is if you have any setup or teardown or transformation, right? So say you have a data object that needs to be transformed as you're moving data over, you can do that during this little step. So you can do a safe migration, right? Yeah, so it's totally possible, you can do it, but I don't know if I'd suggest it, mainly because all I've done is try and break stuff with it. I don't know if it actually worked, but so, this one, mutable string primitives, right? That'd be awesome. But doesn't the ECMAScript standard say that strings are immutable? Yeah, it does actually, but why not? So, in V8, on the native side, we have access to what's called an external string. An external string is a string allocated outside of the V8 heap. And so what we can do is we can create it and then pass a pointer to it to V8 and say, use this as a string. And the V8 does, and it's happy with it. But then, technically, you're supposed to pass in a const, so you can't change it afterwards. But I mean, that's easy enough to get rid of, right? So then you have a pointer to it, and you can just do whatever you want. Let's see. All right, so that's a bunch of... All right, so this create string function is it. Okay, I just had it zero fill a string for me because it's easier. I'm like, oh, well, now this write function writes to that memory. But see here, I'm passing in the exact same string. So I haven't actually performed directly on the string at all, right? It's all just happening by this function, right? It's like, oh, wait, great. I just mutated the native string. And when I say native, I mean it is a full-fledged primitive. You cannot assign anything to it. Like, you can't do anything with it except for the very small explicit set of operations that V8 allows. And then at first I was like, okay, well maybe I can use this for a performance thing, right? Maybe I can, right? I'm going to take a substring, and then I'm going to write something else to it, and then I'm going to print them both out, see what happens. It's like, yes, all right. I have like maybe a performance thing that I can use specifically for I was thinking the HTTP module, being able to read in headers and slice them out on the fly so I don't actually have to allocate more memory. So just uncommenting is easier. All right, so here I'm creating now this other one. Sorry about the highlighting. It's a macro I have to just auto-highlight anything that matches. So I'm going to print the buffer, print the string. Now, so this function up here, 2 mutable strings. So basically, I'm creating a buffer of 12 bytes and filling it with $b, and then I'm actually creating a string out of it, right? So what happens is, basically the buffer is tied directly to the string. So now I have 2 objects, a buffer and string, a primitive string, and everything that I write to the buffer shows up in the string itself. So they're linked via their data pointer. So like you can grep on, or not grep, you can regex search on it and do whatever else you want by just mutating the buffer itself, and it'll turn over. And then this one, I was like, all right, great. That's awesome. I'm going to create a string. Well, I created this function called setPointer. You can see a little bit lower. And what I'm going to do is actually take a string, and then I'm going to, on the fly, replace the pointer. So the string primitive actually will repoint to another chunk of memory. Like, nothing can possibly go wrong with this, right? I'm like, great. All right, so that's looking good. Let me go ahead and see what happens after I do this. What? Oh, yeah. So I replaced the string pointer with the buffer pointer, right? And under the hood, I tried to make it as safe as possible to, free the old memory, because it shouldn't have been, there anyway and whatever. But yeah, I take an existing string primitive and I replace it with the pointer of an existing buffer, so then it then reads that memory. I know you all just think this is super helpful. I'm sure all of you are going to run out and be like, boss, we've got to deploy this in production. So, when I did this, I thought, all right, you know what? This is going to be a great thing for performance. So I just have to see how it does comparatively to a binary string. Like, you just take a buffer of 1 kilobyte, turn it. So all right, great. So 192 nanoseconds to execute. All right, so awesome. That's amazing. I just reduced the time, right? It's working out so much better. So let me see if the set pointer method's even faster. It is. Yes, it's so amazingly fast. No, I'd seriously hold off that for a second. So if we go back up here, right? Oops. All right, so binary string, let's see how fast it is. Okay, so 3.7 microseconds, not horrible. The right, .1, great, okay, I saved myself 0.6 nanoseconds, or microseconds. Now the set pointer, this has got to be just a hair faster than the other, right? But what? I must be freaking amazing, because I have solved a performance problem for everything right here. Yeah, no, that's no. So, yeah, wondering why that was even possible. And I'm a hair over time, so I'll end on this. All right, I was like, okay, great, I'll do this. I'll do this. Whoops. Where did that die? What? Hey, Trevor, wait. Okay, so here you can see I create a new one, and I substring it, and then I fill the buffer, and I write it to it, and then I print the substring again, and oh crap, the substring changed. That might be problematic, because I don't want my headers to change on me like on the fly, or like, well, maybe I do, but that'd be maybe a useless server. I'm like, okay, well, maybe the pointer one be, for whatever heavenly reason, maybe that one's correct. I don't know. So let's see. A what? I don't even understand what the character is. Let's do it again. What? No, there's got to be some issue. Ah, what the crap? Yeah. I honestly have no idea what's happening. I've dug through V8 source for a few hours, and I don't know how it's managing to pull out a random data set of I don't know where. So, okay, maybe not that safe. Well, okay, it was never that safe to begin with, right? But it was a fun experiment. And for a brief moment, I had a glimmer of hope that I really had solved all of our performance woes. So, wrapping this up, performing matted scientific experiments won't kill you, but it will blow up in your face. And that's okay, because it is so worth it. It is so much fun to figure out how to do something, and you are convinced nobody else has ever figured out how to do this before, right? And then to find a solution, I mean, even if it doesn't directly apply to what you're doing, I found so many times it allows me to go back to previous solutions and then tweak it and realize, oh, wait, I can totally change this around and have a much faster and more reliable solution, right? Because I already know exactly what doesn't work. Anyway, thank you very much.